Okay, so now that we know what a mixture problem basically is, let's develop a game plan to figure out how to solve them. And it turns out that when we're doing a mixture problem, we're going to have two equations. And the first equation, I always kind of call it the freebie, for lack of a better name. Because all you have to do is take your two variables, right? There's going to be two unknowns in these. You take your two variables, you add them, and they should represent some given total. So I always call that a freebie. You know you're going to take your two unknowns, add them together, and it'll always equal some total that's given in the problem. Freebie. The next equation is a lot harder, and for lack of a better phrase, I like to call it the strength equation. What usually happens in the strength equation is there's some multiplication. So think about the video we just cut with regards to finding the number of 3-point baskets or how much acid that we had, right? If you go back to that, I was performing a multiplication to represent some totality. So there's usually going to be some number multiplied to x, there's going to be some number multiplied to b, and that's going to equal another total that's hopefully given in the problem. And I like to call that the strength equation because how strong is x? Well, if it's 3 pointers, it's 3 times as strong, right? If y is the number of 2 pointers, then it's 2 times as strong. If I have a 15% solution, right, we have 0.15. And if I'm combining it with a 7% solution, we have 0.07. So how much do I have of each? And then how strong is each one? And they both represent some equation that represents a total. And you can see in a mixture problem, there's going to be two unknowns. I now have two equations. There's our setup. We're ready to solve the system. So that's what things are going to look like. So let's see it in play. And then, of course, once we have a system, we can basically use our equation solving skills, whether it's graphing or algebra, to solve it. So here's another word problem. Let's see this in action. So a pharmacy sells Novolin for $20 a vial and Humulin for $25 a value. If they sold 50 vials and made $1,185, how much Novolin and how much Humulin did they sell? So classic mixture problem. We're mixing two different types of vials. So we're going to begin this journey by talking about my unknowns. So X is the number of vials of, let's say, Novolin, and let's say Y is the number of vials of Humulin. Alright, so I've got two unknowns, so I need two equations. So as I told you, what's going to happen is we're always going to end up with a freebie, and we're always going to end up with something that's a strength. So in this case, my freebie is X plus Y equals what? We're talking vials and vials, so they better equal to the total amount of vials that I have. So X plus Y is equal to 50. All right, and now we're looking for a strength equation. Well, each Novolin bottle cost me $20. So how much money did I make from that? That would be 20 times X, the strength of the Novolin. Plus, well, each Humulin vial cost me $25. So 25Y would be that. So the dollars coming from the Novolin plus the dollars coming from the Humulin better be equal to the total dollars that we had all together. There's your setup, right? I basically take into account everything in the problem. I have two unknowns. I have two equations. We're ready to solve this. How do we solve this? Well, you can graph it. You could substitute, or you could eliminate. The choice is yours. So how about now what I'm going to do is focus on the solution, the setting up, and then in some other videos we'll talk about the actual solution itself. But again, notice for a mixture problem, we have a freebie, and then we have basically a strength equation where there's a multiplication going on. So let's set up a few more of these, and then we'll come back in future videos and we'll actually go through the solution part itself. But if we can't set them up, we're in trouble. So let's focus on the setup.